Let's begin. Today is May 8th, 2024, and welcome to the Daily Turing Machine Puzzle. Notice that today's puzzle has 5 criteria cards and 5 verification cards. But before we begin, I do want to share with you one additional feature about the Turing Machine Puzzle. So at their website, turingmachine.info, the one thing that differentiates this puzzle from any other online puzzle is that you can actually search for previous puzzles. I don't think of many online puzzles that offer you that ability. So yesterday's puzzle, if you recall, looked like this. And its unique identifier is B5H4MJ. And obviously it has these criteria cards, a little bit difficult to see, but it's 1, 13, 17, 19, and 20. So let's go to the website and actually search for this puzzle. So you're going to go to problem search and you're going to input that unique identifier, B5H4MJ. Click load and then generate. So notice again, here are the criteria cards, 1, 13, 17, 19, and 20. So again, that's one thing that I really like about the Turing Machine Puzzle board game, is that you can always search back for previous puzzles. The one slight thing I will notice is you don't see the date that it was for the daily puzzle, but nonetheless, we are able to test the code, compare it to the results to the Turing machine, and basically just a general experience. So let's actually do today's puzzle. So I'm going to go back home. I'm going to the daily challenge. I'm going to generate. And again, today's puzzle has those 5 criteria cards, 4, 9, 16, 19, and 20, with the green verification color scheme. And again, its unique identifier is listed here with today's date. So let's actually solve. Okay, so again, our 5 criteria cards are in our little grid box here, with the top row being criteria A, B, C, and in the second row we've got D and E. So let's look at what criteria A will tell us. It compares the middle digit, the square digit, to the number 4. It'll respond whether the middle digit is less than 4, equal to 4, or greater than 4. Criteria B will tell us the quantity of number of 3s within our code. Are there no 3s, 1, 2, or possibly are they all 3? Next, criteria C compares the number, the quantity of even versus odd digits in our code. Are there more evens than odds, or are there less even than odds? Criteria D takes the sum of the first 2 digits, the triangle and the square, and compares that sum to the quantity of 6. Is the sum less than 6? Is it equal to 6? Or is it greater than 6? And finally, criteria E will inform us whether our code should have no repetitive digit, meaning they're all unique, like in the example 1, 2, 5, or should the code have a pair or a double pair of digits, in this case 1, 1, 2, or could it also be that all the digits are the same, as in the example 2, 2, 2. Well, as normally, I will begin with my proposal of 3, 1, 4. And so let's begin. I think I'm going to test criteria C and verify how many even to odds there are in the solution. Remember that we are looking for a 3-digit code where each number goes from a range of 1 to 5, and that this unique code must comply with all the criteria that we've just talked about. So again, let's test C. Okay, so C returns false. The Turing machine tells me it is incorrect. My proposal does not meet this criteria. Notice that I do have 2 odds and 1 even. Since that is incorrect, that tells me that no, I shouldn't have more odds than evens. So in my notes, I'm going to state for criteria C that there are more evens than odds. Okay, so since my proposal had 2 odds, that is incorrect. I should then indeed have more evens than odds. Now, I don't know if there are 2 evens and a single odd, or potentially they could all be even. I still don't know that. We'll have to be testing other criteria to sort of figure that out. And given that, there's really nothing I can eliminate since this is very general. It's not specific to any one digit, whether it's triangle, square, or circle. But I do know that I have more evens than odds. That said, I could potentially test whether there is a single 3. So let's test that. Let's see if the one odd that may be in our code, is it a 3? So let's test that. So let's test B. Okay, so we know from the Turing machine, since I do have a 3, that means that there is no 3. And that again was for criteria B. So there is no 3-digit. Now, that doesn't mean that there is no odd. That just means that if there is an odd, it won't be a 3. And that said, I guess since there are no 3s and we know that there's only 1 digit, I feel confident that we can eliminate all the 3s, right? So we know obviously there can't be 2 3s since we have more evens than odds. And the fact that the Turing machine just told me that no, there is no single 3, that means that, yeah, I can eliminate all 3s. Okay, but again, 1s and 5s are still a possibility. Let's see, what else do we know? So we kind of divided our, digits from, less than 3 and greater than 3. I'm trying to see what we can compare here. This will tell us a little bit about blue and yellow, and anything is possible. We could have values that are greater. Let's do this, since we do have more evens than odds. Let's see if there's any indication as to whether there are any pair of digits, or should they all be unique. So let's actually test E. Okay, so it is correct that they all should be distinct. Notice in my proposal has unique digits 3, 1, 4. The Turing machine confirms that yes, our final code should all be distinct. So that means that the notes I will put for criteria E is that all digits are distinct. And furthermore, since we know that there are or at least 2 or more evens, since they have to be distinct, that means that I need to have, I'll update these notes here that there are in fact 2 evens. There are 2 evens, and specifically 2 and 4, since they have to be distinct, and there is an odd. There has to be an odd and an odd. Okay, so at least that gives us an idea of what we're going to be looking for as a new proposal. We are done with our 3 tests, so we have to come up with a new proposal. So we definitely have a 2 and a 4, and we need an odd. Okay. So notice that none of the criteria cards have a purple circle to sort of exclude or to further confirm what it may be. So my takeaway from that is that somehow the other criteria will sort of force the circle to be a certain quantity. So if that were the case, so one thing that I may test in the future is whether this is a 6. Well, we know we can get a 6 by adding 2 and 4. So that would mean that the purple is an odd. But there's nothing else in here that would lend itself to figuring out whether it's a 1 or a 5. Right? So there's no way to distinguish 2, 4, 1 and 2, 4, 5. So that leads me to believe that the odd has to be either triangle or square, and that the other even has to be the purple circle. So notice that criteria A either forces, there's an equal 4 or potentially less than 4. And between those two, again, I don't know which one's odd, since 2 and 3 are both less than 4. Maybe that won't be the best way. So I'm thinking the square is going to be a 4, and the odd is going to be triangle. Now, notice that I also have a sum. So if this is a 4, if the square is a 4, I'm trying to think of I don't believe it's going to be a 6, so it's either less than 6 or greater than 6, and there's no duplicates. 4 and 5, 4 will give me a 9, and that's pretty unique. I believe that may be the only way to get something bigger than 6. Whereas if it was 1, 4 or 2, 1, 4, actually 1, 4 also is unique. It's less than 6, and that is an odd. So one of these, it's either going to be greater than or less than, and I'm hoping that the square is a 4, and therefore the circle is going to be a 2. So let's go with 1, 4. I'm thinking it's going to be less than 6. 1, 4, 2. And let's see if that is correct. So again, I'm hoping that will be less than 6, and that this is exactly 4 to force a circle to be 2. So let's see how we do. All right, so first, let me actually test the sum. So that's criteria D. Okay, so it's not correct. So I'm thinking then, if it's not less than, obviously it's going to be greater than. And so before we actually test any other criteria, what can we do to get a greater than? So 2, 5, or I should say 5, 2 would work. And 5, 4 would work. Of course, not 5, 5. So once I figure out what the square is, that may help us to figure out what the triangle will be. And so maybe it may be reversed, or maybe, we'll find out. I won't get ahead of myself. So let me test A. Okay, so A was also incorrect. It is not equal to 4. Oh, and let me go back to A, and A was false. Or sorry, I did D first. So the sum. So let me say that the sum for D of triangle and square should be the sum of triangle and square. So again, I'm pretty convinced that it can't be 6, because if it were 6, then I don't know how to distinguish between 1 and 5. So I'm I think my deduction is correct. And since it failed for less than 6, I'm going to say that the sum is greater than 6. So the sum is greater than 6. And before I do any kind of elimination, let me go back here in the notes and say that the square is not equal to 4. So I'll say square is either less than 4 or square is greater than 4. Okay, so let's see. I don't think I need to do any other test this round. B, we know that there is no 3, and I guess I guess that means that there is. I should have maybe updated earlier. There is a 1 or 5. Okay. So we know there's a 1 or a 5, and that the sum has to be greater than 6. So that means if it's greater than 6, that means there can't be a 1. It cannot be a 1, because 1 plus 5 is 6. It's got to be greater. So that means I can actually eliminate all the 1s. So in fact, then, that means that there should be a 5. So one of these digits has to be a 5. And it's going to be one of the triangle or square. So it could be 2, 5, and then 4. And in fact, yeah, so the only combination is 2, 5, 4, 5, and of course the third number, the circle, being the other even. So we know it's not 4, but could it be a 5? We don't know. So down here, so these are the possibilities. It could be, we'll say 2, 5, 4. That's one possibility. It could be, it can't be 4. It can't, actually, triangle could be 4. It could be 4, 5, and then 2. Let's see, what else could we have? Yeah, 2, 5, 4, and 4, 5, 2, and then it could either be 5, 2, 4, or 5, 4, 2. So all of these first two digits do give us a sum greater than 6. There is an odd, and then there's a 4, and they're all distinct. So this test, we need to somehow distinguish between all of them. So, well, we can eliminate actually this one. We can eliminate 5, 4, 2 because we know square is not 4. It's either less than 4 or greater than 4. So notice then, if I take a look at these two proposals or possible solutions, they both are greater than 5. Or sorry, greater than 4 for criteria A. Square is greater than 4 in both of these cases. So there's no way to distinguish between these two possibilities. They would all sort of meet the criteria. And so therefore, since it's ambiguous, that means that cannot be, either of these cannot be solutions. It would have to be 5, 2, 4. Okay, so I'm going to cross these out. And again, based on deduction, I'm stating that the solution should be 5, 2, 4. Okay, so let's again go back and think about this logically. So I deduced So I deduce that it should be less than 4 because I have two cases where it's greater than 4 that I was unable to, you know, pick one from the other. They're identical in some sense. So I deduce that it should be less than 4. So that means it's going to be a 2. And because the sum has to be greater than 6, the only thing I can add 2 with to get something greater than 6 would be a 5. Hold on, let me, oh no, I apologize. The 2 is down here. The 2 is a square. So the only thing I can add to it, triangle, would be a 5. So that's why it's 5, 2. And that would force a circle to be a 4. Okay, so it looks like the logic is sound. Let's actually confirm. And so at this point, yeah, let's actually confirm it. So 5, 2, 4. So test the code. 5, 2, 4. Verify. All right, fantastic. We got it. And so let's actually confirm or compare our results with a Turing machine. So let's actually see the results here. And that was that B, C, and E were tested first. B, C, E. And E was correct. And the second round we did A and D and they failed. A and D failed. Okay, and how did we do? How do we compare to the Turing machine? Wow, look at that, fantastic. So we did it in 2 rounds, 5 questions. Turing machine accomplished the same in 3 rounds, 7 questions. So just as an example, getting incorrect information from the Turing machine is not a failure. Again, that's helpful because we eliminate possibilities. So don't get discouraged if you get X's. And also, one additional strategy, notice that I did list out what I believe to be a complete list of possible solutions. And especially right here, this is a skill that slowly you'll need to develop, is to sort of look at potential solutions, and if you cannot distinguish them, that means that they cannot work. So again, I didn't have to test criteria A twice to figure out, to deduce that in fact the square had to be less than 2. It could not be less than 4. It could not be greater than 4. Okay? Well, if you like this video, again, please give it a thumbs up. And if you don't want to miss out on tomorrow's puzzle, please subscribe so that you can be notified. Well, that's it for today. Thank you. Have a great one.